Hi everybody, the 3rd of May 2024. Today I'm going to talk about our basic circuits, and we'll talk about how to analyze circuits, especially more complicated circuits. Well, let's get back to the concept of some parameters or some factors in circuit. Basically, we have the voltage, right, in the unit of volt, current in the unit of ampere, and resistor in the unit of ohms. For very simple circuits, you talk about where you have only one source voltage, one resistor in series, and then you connected both of them to ground. For the voltage in physics, this means the work done. Okay, let's talk about the current first. The current actually come from electron movement. You have free electrons, right, in some kind of materials or in your circuit, but the current is moving in the opposite direction of electrons movement. And you know that the electric force, when you have the same type of charge, either negative charge or positive charge, they will repulse each other, right? But if you have the opposite type of charge, they will attach to each other. So to make a free electron moving, you need to apply the work that's in terms of physics, from one point to the other point. So that's come into the voltage. The voltage is the work done to move one electron from one point to the other point that's far away. And so the unit of voltage actually is that the unit actually is volt in electronics. But in physics, we're talking about the work done to move one electron from one point to one point. So the work is the unit of joule, and the charge, the unit of coulomb. So actually the voltage is in the unit of joule per coulomb. For the current, that's going to be how many charge at one point, specific point. You want to see how many charge moving across that point in the unit of time or in second. So the current actually has the unit of coulombs per second. And for resistor, that's the unit of ohms. But if you're talking about some other components, for example, capacitor or inductor, that the ohms dependent of the frequency. So you have the ohms in the term of a complex number, or we just call we don't call it resistance, but we call it inductance, right? I'm sorry. Impedance, sorry about that. And for resistor, you know that that's the resistance frequency independent. That means that it's not changed with the frequency. That's different from impedance of capacitor and impedance of inductor. So that's kind of a very nice set. You have like three parameters come to play in the circuit. One, you're talking about resistor. That's frequency independent. I mean, the impedance. But for capacitor and inductor, that's the frequency dependent. And you also have impedance of capacitor when you have higher frequency. The impedance is getting higher, but for inductor, the impedance, when the frequency higher, the impedance drop down. You know, just like equation for XL, that's impedance of inductor. XL equal to 1 over j omega L, where omega is 2 pi f. Where the f is the frequency, the angular frequency rate, and the impedance of a capacitor is the Xc equal to j omega c. I'm sorry, that's opposite around. J omega L, when the frequency is higher and the impedance is getting higher. But for a capacitor, when you have higher frequency, you know, the impedance drop down, because the impedance of a capacitor is 1 over j omega c, right? So that's perfect. One is not frequency independent. One is the other two, the frequency dependent. Once when frequency get higher, the impedance drop down. And the other one is that when frequency is getting higher, the impedance is getting higher as well. Now you look at the circuit. The simple circuit that you're looking for, you need only one voltage source and one resistor connected in series, right? And then both of them, you know, the other terminal connected to ground. So the current, you know, will flow through the closed circuit. And now when the current flowing to resistor, and you know that resistor is come from resist, that's the verb, that means against, you know. The higher the resistor, the resistance, the lower current will flow through the circuit. And then to have a current flowing, let's say through your resistor, you need to have the voltage different between two ends of the resistor, right? If the one is on the left, you have higher voltage than the other end on the right. That means the current will flow from the higher voltage to the lower one. And you only know the voltage drop across, you know, resistor. That means you apply equation delta V or V2 minus V1 equal to IR. That's Ohm's law. But if the other end of a resistor connected to ground, you know that the voltage at the right end is 0, so you can find the voltage V2. I mean the other end on the left of your resistor. So that's the voltage drop across the resistor. And you also know about the heat dissipation, because when current flowing through resistor, you have voltage drop across resistor or across components. When you talk about our, other components. For example, capacitor or inductors, that's going to be another more complicated issue. So that's why you have a heat dissipation when you have voltage drop across resistor. The same thing as you have the heat coil. When you turn on your stove, you can do cooking, right? Because you have heat dissipation. And of course, you lost some, the voltage is just like energy. The work is just like, energy. You need to apply energy. So you lost some energy. But with by conservation energy law, right? You never lost your energy. It just, transformed to the other type of energy. In this case, you have maybe you have battery. That's from a chemical energy, right? The flashlight energy. The flashlight battery. That's going to transform. That's give you electric current or electric energy, and that's been part of them. If you drop across your competence, in this term is resistor, so that's become heat, and you still have the current flowing through the circuit. There's also another type of together electric energy. From battery, you convert chemical energy, right? You have battery, you have chemical stuff inside the battery, and that's give you electric energy. What about solar cell? You transfer the radiation energy, into electric energy, right? Because you have strong sunshine and you have like a solar panel exposed to the sunlight, and then that give you electric energy. So you can apply to a television or whatever electric appliance. What else? For generator, you transform the mechanical energy, right, or potential energy into electrical energy. That's just for example. There's so many type of electric energy sources. And then that's we talk about the circuit. And you're probably familiar with the Kirchhoff voltage law, or KVL, and Kirchhoff current law, KCL, by the short, the abbreviation. Where in the circuit, sometimes you have many branches, you have many components connected, to one node in ODE. By applying KCL, because in this term in the circuit, we're going to analyze, your circuit, looking for what is your voltage at each node, what is the current flowing through your components, each component. So you apply KCL, Kirchhoff current law. That states that the summation of the net incoming current into that node going to equal to outgoing current from that node, or summation I out equal to summation of I in. That's KCL. And you have let's say you have I1 to I6. You are looking for six equations, to solve, for current or currents. And sometimes you need to apply metrics. That's why, mathematics come to play in the circuit to be able for you to solve for the current and the voltage. And KVL, Kirchhoff voltage law, states that the total, the voltage drop across each components going to be equal to 0. That's related to conservation of our energy, or energy never lost. It just transform into the other type of energy. For example, in the term of heat. And or you can say that the voltage source, that's some type of energy going to separate into the voltage drop across each component. If you're talking only you have resistors in your circuit, just make it simple, right? So V source going to equal to VR1 plus VR2 plus VR3 plus VRN, or summation of VI when you have n components. And then you can set up equations cooperate with KCL, or the current equation, to be able to solve for the voltage at each node, at each point, and the current that flowing through each component, right? So that's the basic concept to get it started. And if you understand this concept, when you come to deal with more complicated circuit, that means you have so many, it's just like circuit network. You have many R. It's not only connected in series, but some of them are connected in parallel. You need to apply KCL and KVL and Ohm's law. That's all you need. Start from the simple problems, and then getting more complicated problems. And if you understand this concept clearly, you'll be able to tackle problems. And that's very important. Why? Because for example, if you have external devices, from the output of your circuit, you have source voltage, right? And you have components, in this case like resistors. You connect LED light emitting diode. You connect the output to the fan that you want to, the fan working, or motors. You need to make sure that you have the current, the maximum current flowing to that kind of external devices, because they have some kind of the power rating, right? That means you have a tolerance. What is the maximum power that kind of device be able to stand? Otherwise, it's going to be overheat and it's burned out. That's not what you're looking for. So you need to be able to calculate the current, and the power actually, like equal to the current multiplied by the voltage, or P equal to IV. And the power, that's the unit of watt, W-A-T-T is. Watt is the energy per second. That's the definition. You learn about that from high school. Joule per second. So they have the watt rating. Every electric appliance, the households, electric appliance, you have power rating. So you don't want to have like the over power rating. Otherwise, it's going to like overheat and burn out. Okay, so that's all the basic concept of a circuit, or how to analyze your circuit. And now let's move to you're probably familiar with Thevenin theorems and Norton theorem. What is Thevenin theorem and Norton theorem? Well, for example, if you have like the block of your source supply, or the source voltage, Sometimes you have more than one source voltage. You have V1, V2, V3. Maybe they connect to competence in the opposite or turn around. Sometimes you have like negative and positive. Sometimes you have a positive and negative. You know, upside down. You can say that. And you might have more than one resistor in your source, supply. And you have the final terminal that you want to connect to your external devices. In terms of motors, in terms of LED, electrical appliance. So you want to simplify, why not have only one source voltage and one source resistor connected in series, and then you just connect to your external device. They're all connected in series, right? Easy to calculate for the current flowing through your external devices. The Thevenin theorem states that to find, you need to represent all the source voltages into one, and you need to simplify many source resistor into one, and V that's become VTH. TH stands for Thevenin, and RTH is just like Thevenin resistor. Okay, now how do you find VTH and RTH when you have so many voltage sources and many resistors in your supply? Well, what you can do is that I don't want to get into detail because I don't have like piece of paper to write down equations. Just think about okay, I just show you about this one. Hopefully you can see. Let me move closer. Here. All right. Here is your original circuits. You have so many voltage sources and you have so many resistors. And you want to apply Thevenin theorem. And then you end up with only one voltage source, VTH. And you end up with only one resistor, that's RTH. Whatever you do when you connect your external device, the current flowing into that device, which have internal resistance, right? Or you connect to the original circuit, the current flowing to your external device has to be the same. But you have more simple circuit. Okay. What you can do is that by applying Thevenin theorem, you're looking for VTH. VTH is just you look for open circuit. What does it mean open circuit? You just focus on your terminal, the output. Your circuit, that's mean you have a output resistance to be infinity, right? So you have resistance so huge, and the current will not flowing through this R. And that's what you're looking for, is that you were looking for the potential at this point. When you have open circuit here, you have no current flowing to R4. This is my R4. Because there you have the same voltage. By applying Ohm's law, delta V equal to IR. When you have no current, because this is open circuit, right? You have no current flowing. So your delta V have to be 0. And you have, if you put this one as V2, this is V1. V2 going to be equal to V1. So that's you're looking for. All right. the voltage at this point. And that's become V open or VTH. And you can put this just right here. What about RTH? Well, for RTH, what you can do is that you can short on the voltage source, okay, and then for the RTH, you need to apply Ohm's law. V equal to AR, so R equal to VOI. You already have V equal to VTH, and I, that's going to be a short circuit. What does mean short circuit? Short circuit, this means you just short, the terminal, the output terminal, and you're looking for the current flowing through, R4. That's become a ISC or short circuit, and you can find RTH equal to VTH divided by V open divided by ISC or short circuit. That's in practical. Okay, you have meter, right? You can use your meter, to measure the current, flowing by connect your multimeter in series with R4. And for the voltage, that you need to measure by connect your multimeter in parallel with terminal. Does have a resistor in there. All right, so that's, you're going to have what? Both V open, I short, and then you can look for what? RTH, and you can just look for RTH. Pick up your resistor that have a resistance at that kind of value equal to RTH, and you can just apply VTH as the V open. And also about Norton theorem, that actually for Thevenin theorem you're talking about the current source, voltage source. But for Norton theorem you're talking about the current source in parallel with R Norton or R NOR. Now how do you find I NOR, I Norton? You look back at the original circuit. It's the same thing as the I short. Okay, you already have I short from Thevenin theorem. And what about R NOR? Same. R NOR is going to be calculated from VTH or V open divided by I short. Okay, and you can look for the current source. You can adjust, this is the current that I'm looking for, that I need, and look for resistor that have a RTH resistance and connect it in parallel. Okay, and that's all for today. I don't want to, take too much time, and I will do it later on or add up, something getting more complicated. Okay, everybody, bye.